Somebody tell me, let's fill in all this information. So it says the slope is the measure of the what of a line. Do you remember the word? Quick. Girls, Sydney, what's the word I'm looking for here? Slope is the measure of the of a line. Say it louder, Miles. Steepness, right? Steepness. Well, because he listened yesterday. He has a great memory. Steepness of a line. Okay, that's a word. Steepness of a line. Yeah. Okay. Okay. Slope is the ratio. Kale, you fill this one out. The slope is the ratio of the vertical change called the blank over the horizontal change called the something.
Rise and run.
Well, thank you, Kale.
Rise and run.
Excellent. Rise over run. Simmer down, boys. Okay. A line segment which rises from left to right. Sydney can answer this one since she's talking. A line segment which rises from left to right has a what kind of slope? Hey, stop. Positive. You guys. All right, Joey, you know this one. A segment that falls from left to right is negative. All right, well done. So Joey's on this. Okay. Horizontal lines. Okay, think about this one. A horizontal line segment has a slope of yes. And a vertical line segment has an undefined. Okay. Okay, none of those expletives. And the slopes of all line segments on a line are equal. Good job, wow. Just nailing it. They're equal because a segment is a, hey, Jace, over here. A line segment is a what? What do I mean by segment? A section, a piece, a chunk, yeah. So if you have a piece of a line, will have the same slope as the entire line, right? Any piece on it. Okay, let's go. So if it said, find the slope of the line segment AB. Okay, go, what is it?
1/2.
Okay, no, tell me the whole thing first. It's up 3 over how much? Okay, so then that's how we get 1/2. Okay. Then it says, list the coordinates of the endpoints. So what is the coordinates? Now, y'all, when I ask you for coordinates, I want coordinates. You got to know what that word means. Some of you didn't know that on your test. Speaking of tests, are they all done? No, I didn't. I was waiting for someone to finish. Victor, today. Okay, that's why I was waiting for. Okay, what are the coordinates of point A? Quick. 1 and 8. What are the coordinates of point B? 7, 11. Okay. And remember, coordinates always have 2 directions to get to one place. You have to give the x coordinate and the y coordinate to name the coordinates. It says, now, how can the rise of the line segment AB be determined? What if you just had the values of the y's? So we just look at the y values of these points. Check it out. Look at this. Stop talking. Actually, just move to over here. If you're going to talk, you can move. Come. Danielle, move. Well, you're the one talking. Okay, well, because when I look behind me and I look at you, you're the one talking. What is the rise? Can I tell what the rise is just from the y values? Look from 8 to 11. Can you tell how far it's changing? 3, right? From 8 to 11 was a rise of 3. What's the run if I just want to look at the x coordinates? So I'm just looking at the x. Can I tell what the run is? 6. So I go, oh, okay. So I can say 3, that's the rise over the run. All right, now, here's what you can do to find that. Given just the coordinates. So all I have is this. Here's what you need to do. Take the y value and subtract the other y value from it. That's how we got the 3. So we went 11, write this down, minus 8. That was the rise. The y values tell us the up and down part, correct? So I'm taking this 11, this pink 11, and take away that 8. And then on the bottom, I'm going to take the 7 and take away the 1. That's how we got the 6, correct? You with me on that so far? Okay, now, so that's what that equals, which of course is 1/2. All right. Let's do the same thing with CD. All right, I just did F, so let's do CD. So if I wanted to not count, I don't want to, let's pretend they gave us the coordinates, but we don't want to have to go graph them. Can we do it just from the coordinates? So what are the coordinates of C? Can you tell me the coordinates of point C? 2 and 5. And what are the coordinates of D? 6 and 2, right? We're right on 6 and 2, I think. Step back to look sometimes. Yeah, 6 and 2. Okay, just from those coordinates, without looking at the picture, could I determine what the rise is and what the run is? Victor, looking at these two coordinates, what's my rise and what's my run? Can you tell by looking? What's the rise? Abiogenesis. Pay attention. How could I find the rise just by looking at the coordinates and not by looking at the graph? Jeffrey.
Take because of this first value, so take the difference between existing.
Okay, 6 and 2 are the x's. That will go this way. You can tell what the run is by looking at the 6 and the 2 from the x values. Correct? That'll be the run. The rise values will come from the y's, right? Somebody? Abby, does that make sense? So I can see that I went from 5 to 2. What was my rise? 3. Do you want to call it negative? Yeah. Here's what we're going to do. Let's write down a formula for it. Go y minus y. That will be the rise. The run is x minus x. Rises over runs. The difference in the rises, up and down, over the run. Make sense? Okay, now what we have to do, the only part, in the book, they do a bunch of this. They put little two, don't write this down, don't write it down. They put 2 and 1 and 2 and 1. And I used to think when I was in high school, you always had to take the second point and subtract the first point from it, on the top and the bottom. I didn't know you could go the other way around. I didn't know, because I looked at that little formula and I understood what they said. So I said, okay, this is my second y value, subtract your first y value. But then I learned, as I got more intelligent and became a mathematician, that you can go either way. You just have to be consistent. If you want to start with the first y and subtract the second, like we just did, we went 5 take away 2, and then you want to do the bottom. If you're starting with this 5 in this coordinate, then you have to start with the x value there. Do you understand what I'm saying? You just have to start with the same coordinate each time on the top and the bottom. Okay, so if we did it this way, we would get 3 over -4, correct? I'll prove to you that we could have done it the other way. We could have said, we went 5 minus 2 for the y. I could have gone 2 minus 5. But then I would have to do 6 minus 2. Agreed? You got to start from the same place. So what are we going to get? -3 over 4. Look at that. Same thing. Because I don't care where the negative is. It could be the top or the bottom in the middle. It doesn't matter. You get the same thing. You just have to be consistent. And do you know what I mean by consistent? Stand up if you know what I mean by consistent. You have to go from the same direction. Okay. Okay? All right. Now, let's go back and check and see, was that right? Do I have a negative slope from C to D? If I look at the picture, is it negative? Victor, is the slope negative from C to D? Yes. Is it going down 3 over 4? Yes? We're right on. Okay? All right. Next page. So here is your formula. I don't like the formula. I don't like the 2 and the 1 part. I don't like that. Just go y minus y over x minus x. It's the difference in the rises, which are the y's, over the runs. Okay? Rise over run. You can put the little 2 and 1 in there if you like it. You can have it, but you don't have to do it. So if I just, okay, I'm going to skip all this. I don't care about that. When it says, I need to find the slope of a line that goes through those points. Here's what I want you to write down for slope. Y minus y over x minus x. Now you choose. Do you want to start with the G or do you want to start with the H? Doesn't matter. Pick. Hurry. H. Let's start with H. So I need to take the y values from my h's and go -2 minus 8. That's the difference in the y's. So if I'm starting with minus 2, what do I have to put next? On the bottom, 7, right? I have to go 7, take away, now here's where the mistake comes from, on negative 3. Don't forget, you have to put down the extra negative sign. You have to. So then this becomes, what's the top? Negative 2, take away 8. Negative 10, and the bottom is, don't forget to do that, see? The negative becomes a plus, correct? And so 7 plus 3 is 10, and so your answer is negative 1. Get it? It's not complicated, you just gotta keep that straight. You go in the same direction every time. Y minus y over x minus x. Got it? We're missing Ben. Okay, so let's go see if you can figure out some kids here. So Eleanor, Bonnie, and Carl. Those are great names. I've never taught an Eleanor, a Bonnie, or a Carl. Never done. That's too bad. Those are great names. Okay. It says here, they're calculating the slope of the line segment with endpoints E and F. Their work is shown below. Since their answers are all different, at least 2 of the students have made errors in the calculations. Describe all the errors which have been made and determine the correct slope. All right, check it out. Go take a look. See if you can find if anybody did it right, who did it wrong, and why are they wrong. Take a minute. Somebody thinks Carl is right. Did I hear that? Let's go, Carl. Somebody don't have Carl. You think Carl is wrong?
Yeah, Carl's right.
Okay, let's start with Carl then, since y'all want to talk about Carl. What did Carl do wrong? He went 8, take away 6. That's y minus y, correct? And then on the bottom, he should have done what?
2.
Oh, 15 is right, but he forgot to go minus and then put in the negative 10. You know what I'm saying? Yeah, so he's wrong. It's close. It's close. But that should have been a 15 on the bottom instead of a 5. Okay, so I'll write down here, Carl forgot the negative on the 10. That's what Carl did wrong. That looks like coral. I can do better. Okay. What about Miss Bonnie? She went 6, take away 8.
No.
What?
She didn't put 6.
Oh, so she mixed up the X's and the Y's.
Yeah.
She went 6, take away 8, but then by mistake she went 15, take away 10. She didn't go in the same order, right? Okay, so Bonnie, poor Bonnie. Bonnie mixed up the order.
Sorry. That was Gabe's joke.
Okay, Bonnie mixed up the order. Let's talk about what did Eleanor do. She went negative 10 minus 15. That's good order. What's wrong with her? Oh, she did the X's first on the top. Yeah, she went negative 10 minus 15 and then 6 minus 8. So that's the right way to do it. She's keeping consistent, but she put her X's on the top and it should be Y's on the top. Right. So, right. Yep. Okay. So they're all wrong. This is who, Eleanor? Mm-hmm. Yeah. Okay. All right. So we better go do it the right way. Think of the next question says do it the right way. Oh, no, it doesn't. Does it say do it here?
Yes.
Oh, determine the correct slope. I am supposed to. Okay, this is a lesson. Here we go, right here. Teacher's being a model for you. The teacher's like, I better go read and make sure I actually answered the question. So I go do all their work, And then I have to make sure, do a check before you quit and go on to the next one. Do a quick check on your test, especially. Make sure you've actually answered the question. So it says determine the correct slope. So I just gotta do one little change to this guy over here, right? He had 2, should be 2 over what? 25, right? Because 15 plus 10 is 25. Okay, that's the correct slope. Okay, good? All in favor, say aye. Okay, turn the page. Wow. So far we've learned one thing today. One thing we've learned. The formula for slope is y minus y over x minus x. Okay? And you can do that given coordinates. You don't have to plot it on a graph every time. You can just use coordinates. Okay. The next thing we're going to learn is what this little word collinear means. What does it mean to have a co-worker? What's a co-worker? Someone you're working with, right? You work together with them, correct? Okay, cooperate means you're going to operate together. You're going to do this together, okay? So guess what collinear means? You're going to be together on the same line, okay? We're going to do this together on the same line, collinear, to lie on the same line. So 2 lines in a plane can either be at an angle. Here's your 2 lines. They can be parallel and distinct, totally separate, or they can actually line up together. It's not rocket science. Points that lie on the same straight line are said to be collinear. They're together on the line, okay? Got it? P, Q, and R are collinear. Now, here's what we know from before when we were talking about our segment thing. I mentioned that several times. So what's a segment? It's a section or a piece, right? Chunk. So it says if 3 points P, Q, and R are collinear, if they all do lie on the same line, then this should be true. The slope of the first 2 points should match the slope of the last 2 points, which should match the slope of the total. Agreed? So they're saying this slope right here, the steepness of this part, will be the same as the steepness of that part, which will be the steepness of the whole thing. Agreed? You understand? They're on the same line. The steepness should all be the same. Okay, if it wasn't the same, this would turn, and then they're not collinear. They're not on the same line. Agreed? Okay. Proving, now here's the point you have to know right here. Like I would start this. Proving that any 2 of these, you only have to prove 2, any 2 of these slopes are equal is sufficient for the third to be equal and for the points to be collinear. You just have to pick 2 and go prove that they're the same. You don't have to do all 3. So it says, consider the points A, B, and C. Prove that the points A, B, and C are collinear. So we're going to take any 2 points, see what the slope is, just have 2 of them. Which 2 do you want to do? So let's find the slope of AC, and then let's find the slope of what? Quick. Okay, AB. Doesn't really matter. You could do AB, BC, or AC. Doesn't matter. Pick 2.
Yeah.
What?
The M.
Oh, what does the M stand for? Well, remember this little thing way back?
Oh.
What does the little M stand for? Slope. Mountains. Who said that?
You.
It was Jackson. Jackson was like, M's for mountains. Oh, yeah, Miss Jackson. Hi, Jackson.
No.
Okay, so, hey, so M is for mountain. M is for mountain. Hush, grade 10. M is for slope. All right. So we need to find the slope of AC and the slope of AB. We're not going to plot these on a diagram. That would take too much time. We can do this. So when I'm going to do A and C, I'm going to look here and here. Slope is y minus y over x minus x. Write it down. You won't always have to write it down, but as we get started, I want you to understand every time you see slope, y minus y over x minus x. It's the rises over the runs. Okay, how do we start? Where do you want to start from? You can pick either way you want to go. One way is probably easier than the other, but you can choose whatever you want. Do you want to go 33 minus 3 or minus 3 minus 33? 33. We're going to start here. This is going to be our starting spot. So we're going to go 33 minus, should write 33, there you go. 33 minus, then go get the other one. Right, a negative 3 over negative 7. Take your starting spot, negative 7, and subtract The 5. Okay, so we end up with the plus sign here. So we get this is plus, and we end up with 36 over negative 12. We can reduce that. What would it be?
Negative 3 over 1.
3 over 1. That means you're going to fall 3 and run to the right 1. Correct? Good. Let's go find the slope of AB. So I'm going to erase what I just did up here. Okay, now we're going to talk about AB. So here's another one. Okay. Slope of AB is y minus y over x minus x. How do we start? Where's your starting spot? Quick. 6. You want to start with 6? So this is my start. Okay, I'm going to start with 6. Take away negative 3. Good call. Watch that. And then I have to go 2. Take away 5. My minus minus become a plus. So I have 9 over 2 take away 5. Negative 3, which reduces down. Negative 3 over 1. Check. They're the same. They're collinear. That's all you have to do. Find any two, take any two segments and check to see. Make sense? So what's the one thing you've learned today?
Go in the right order.
Okay, to do what?
Put them in the thing.
What thing? She's good. She's doing good. And what thing? The slope. We have learned how to find the slope using coordinates. What is that? How do you find the slope using coordinates? Say it again. Y minus y over x minus x. Now we're to Danielle's statement. Just be sure to go in the right order when you're putting them into the formula. Could someone tell me in one sentence, what have you learned today? The equation for slope. Tell me more, which is?
Y minus y over x minus x.
And the important part.
M equals mountain.
M is for mountain. Make sure you go in the right order. Be consistent. Right. Okay, here we go. It says find the value of y. Of course, they don't end there. You think you've got it, and then they do something else to you. It says find the value of y if the point D, negative 4 and y, lies on that line segment AC. Okay, so find the point y if that point D lies on the line segment. Okay, no, wait a minute. If it lies on the line segment, what did we just learn should be true? Go back. Points that lie on the same straight line are said to be collinear and will be what? Have the same slope. Slopes will have the same value. The slopes of those will be the same. Right? Did we just talk about that? If there's a point, if it's a line segment, it should be the same. So don't you think we could find the slope of AD? And wouldn't it be true that if the slope of AD was negative 3 over 1, then it would work? It would be on the point, on the line? Right? So you've got this line segment, A, B, C. So A, B, C. If I pick a little point D, if I found A to D and it turned out to be the same slope of A to B, I'd be good. True? Nope. Because from A to B goes this way. Oh, I see what you're saying, actually, Miles. Miles is like, okay, let's be literal here. So it's a negative slope. He wants me to draw it this way. So we've got A, we've got B, we've got C. We know the slope of this is negative 3 over 1. If I want D to lie on the line, then from A going down and over would have to be the same as it was from A to B. Agreed? So let's go make the slope of AD, whatever it is, let's make it equal to negative 3 over 1. So that when I go, because I can put this wherever I want. It's negative 4, and I can put it up or down as far as I need to. Let's put it right on the line. Let's make that y value match. So here's what I'm going to do. My slope of AD needs to be the same as the slope of the previous ones to be on the line. How do I write the slope of AD? y minus y over x minus x. Write it down. Just like that. I need this to be equal to negative 3 over 1. If I'm finding the slope of AD, I need to have my A point written down. If D is negative 4y, what is A? Do you remember? Is it on your book?
5.
A was 5, negative 3. Okay, now this is going to get complicated here, so you have to pay attention. The slope of AD needs to be the same as the slope of my other lines. So let's start with this one. Start there. So I'm going to say y minus, and then I'm going to pick this y value, which is negative 3, over negative 4 minus 5. That's supposed to be equal to negative 3 over 1. That's what I want it to be. Now, Joey, I need you to write this down because you're going to have a question like this. You're going to want to put your hand up. You're going to say, I don't understand what we're doing. And I'm going to say, look back at the question we wrote down. Figure out what we did. Okay. So then, I'm going to go over here. Y minus the minus 3 becomes y plus 3. Okay, good. Over negative 9. Y'all with me on that one? Okay. And you probably already know what the top needs to be, so you're probably already figuring out. What if you can't figure? You know what the answer is, don't you? 24? Yes. Y is 24. How does he know that y is 24?
Well, because it's gotta be divisible by 9.
Yeah, has to be divisible by 9. You want this to end up to be a negative 3 in the end. So wouldn't it be true that 27 over 9 would be a 3? But let's pretend you don't know. It's hard. Maybe it's a funky fraction. Maybe it's a funky decimal. What could you do in this case? You all know what to do. Music to my ears. So here's what we're going to do. If these are equivalent fractions, you can go like this. This is 27. Well, then we're going to go this way. Y plus 3 times 1 is y plus 3. And there's your 24. You can see it now, right? So we subtract 3 from both sides. There's 24. Now let's go find out if I actually answered the question. Find the value of y. Bang, there it is. Done. Make sure I answer. I go back and I read it again to be sure I have the answer. So in other words, now you could actually take your graph paper and you could plot A, B, and C. You could put these 3 points on your big graph paper. It'd be huge, by the way, because you gotta go all the way to 33. It'd be big, make a big graph. And then I could check and see, does the point negative 4 and 24 lie on that line? And it ought to. Make sense? Okay. We're done.